Hola, Ascensioners. This is Ascensioneering. In the last video, we did some fluid flow physics, and today we're going to be talking about hydrostatics. Okay, so this is basically talking about pressure, and this is going to be straight from my little section in the Ascensioneering guide, which you can download. Link in the description, as always. Okay, so hydrostatics. So basically, this is going to be talking about pressure and different types of equations. We're just going to be deriving this bad boy rho GH, which is very useful. And so let's think about the pressure of some liquid in a tank, right? So I'm gonna draw a little tank. Okay, so this is my tank. Okay, so not the best image, but basically this is our tank, and we're gonna have some water right here. And we're gonna say that the water is at some height, okay? Some height h. And what do we know about pressure? Okay, so if this is some area, this is the cross-sectional area, right? Taking a slice, whatever area is bound, that's your cross-sectional area. Okay, so this is the cross-sectional area. Well, we know that pressure, hydrostatic pressure, is equal to, let's say if we apply a force to this object, okay, that's going to be that force divided by area. Okay, or you can write it if you want, if you move the a to the other side. This is the way I remember it. That force is equal to area times pressure. Wait a minute. We can't have that. This is an educational channel. We can't have that. Let's leave it as pressure equals force over area, shall we? Okay. So what else do we have? Well, in the last video we talked about density, and remember that density is mass over volume. Okay, so we're going somewhere, and the volume of a cylinder, hey, I know that. Volume is cross-sectional area times height, which we define. Okay, it seems like we're getting somewhere. So I challenge you to play around with these three equations and see what you get. But basically, this is what you're going to do. Oh, what else am I forgetting? The main bad boy. Force is equal to mass times acceleration. And in this case, since it's a fluid, it's going to be mass times gravity, gravitational constant. Okay, so all right, let's see what we can play around with. So if pressure equals force over area, then I'm going to say that pressure is equal to mass times gravity over area. Okay. And I do have an equation for area, right? If this area right here is the cross-sectional area, right? And if I solve for the cross-sectional area here, is going to be the volume divided by height. So let me see if I plug that in, what's going to happen. This is a little bit differently than the way I did it. So mass times gravity divided by volume divided by h. So h is on top. And mass over volume, that sure sounds familiar. That's right, it's going to be density times gravity times height. And that's it. That's really just it. So in other words, pressure is going to be density of the fluid times the gravitational constant times the height of the fluid. Cool. So in other words, if you go to the pool and you want to see the pressure at the bottom of the pool, all you need to know is the height of the pool, because we know the density of water is 1 gram per centimeter cubed, and gravity is 9.8 meters per second squared. And if you know the height of the pool, you can calculate the pressure. So in other words, we derived a relationship for pressure as a function only for height. So pressure is a function of height. Cool. So this is a little bit counterintuitive to me, and we'll kind of explore this a little bit more in fluid mechanics, but basically, if you think about that, everywhere around you there's fluid, right? There's air. So depending on the altitude, height, that's going to determine the pressure. That's why there's more pressure in a valley and less pressure in a mountain peak. Okay, cool. I think that's all we're going to talk about today. Remember, you can check out the links in the description to go to my website, click the playlist if you're kind of a little bit lost. And next, I'm not sure what we're going to do next. Should we do some problems with hydrostatics, or should we just go straight to mass balance? You let me know. Otherwise, I'll see you next time. Don't forget to share this with your friends, family, and your dog. Yeah.